because
Yeah, let's start
I did
recording.
promise that we're going to record.
Yeah.
This is a first kickoff meeting for Nepio SDK. So welcome. Um, a okay. So the first thing I'll do is let's share that little doc that I had. That I don't expect a lot of people to read the doc, but I did publish that earlier, and I presented that on one of the two meetings. So the idea of the Nepio SDK is this is the one-stop shop of any vendors or any projects, other additional projects, or Win5GS or maybe MacMao in the future, if they want to jump on board to Nepio, they should be able to use these tools and get on board to Nepio. So the core idea is if they're looking to get on, then they could create an SDK, create an operator. So I think because for a very long time people were talking about this as operator SDK. So there's always a misunderstanding, if you will, that this is only about creating an operator for Nepio, which it does do that. It's supposed to do that, but then it's not the only thing. I think John even talked about that today during a SIG meeting, that we named it Nepio SDK because it's onboarding Nepio. It's not just creating an operator. In fact, I would like to think that for network function vendors, actually Saga certainly proved it to us more than anyone else. Any projects or any network function vendors, if they want to write operators, they know how to write operators. It's not like I don't want to treat vendors and network function projects as idiots, and then they're so far behind on the Kubernetes curve that they don't. We need to handhold them for operators. I think that's probably not true. And we are also, if they have their own set of things, then we would like to have a way to actually integrate with what's existing. So the biggest thing is if you have something that is already working, there's no reason for you to rewrite. I mean, to get ease of onboarding is obviously one of the main goals. And then if you have something already working, the quickest way to do it is just use that. And then we have to find a way to integrate with that, with the SDK. And Helm charts is one possibility for quick onboarding, obviously. And then that's common across the board, that all vendors and all the projects, even Free5GC, basically, we got it from Helm charts, and then we start building it from the Helm charts. So people by default having Helm charts is pretty much assumed and expected. So if you have that, I do know Nepio has a lot of efforts right now going on with different Helm chart supports. I am not looking to say SDK is the way to go, and we'll trash everything else, because obviously community is not even following that anyway. So it's just so that if we are using something like Operator SDK, you get that. You get the Helm operator for free. I do know that may or may not be how you want to integrate your Helm integrations, because they do it one particular way, which is putting your value.yaml files into they generate CLDs out of that, and then the operator front end would be watching those custom resources. And that may or may not be what you want. Certainly it's not a Nepio operator, because it's not conforming to Nepio CLDs. So that's a very interesting point to think about moving forward. And then if you already have an operator, which we actually did do that. So I would like to say this. My journey of the product prior to the product becoming Nepio, I've done about 3 different vendor integrations. One of them was using Helm charts for the UPF and SMF, and then by the time we manually converted those Helm charts into either different cap functions or packages, they came back and the AMF was actually an operator already. So that tells me there is a movement in vendors in general that they're building operators anyway to deploy your network functions. And the second vendor we work with, which is the second data point, is that they're already like fully done with an operator. The second vendor we work with is even more advanced than Navio. They have built a very clean cut commercial grade, I would like to say, operators that are being deployed and used on deployments and actual production deployments. So they're far ahead, and there's no reason for us to say just because you integrate with Navio, you have to kind of make your operator dumber because they already support a lot more stuff than Navio CLDs is very simple, obviously, right now. And they would have to they do a lot more than that. They have like slice configurations and all the other things, all based on CLDs. So we get that information too. So those are data points to kind of point to me by saying that the first vendor, the integration was around 2021, 2022-ish, beginning of 2022-ish. So I would imagine, I wouldn't be surprised most of the vendors that have network functions that goes to Kubernetes would likely already have some form of operators that are already built. I actually think this is probably the most common case. If we are successful in bringing vendors on board, the most common case is vendor already has operators, already have something that would allow them to deploy things on Kubernetes, even if they don't use operator. But I mean, why not use an operator? So our job as an SDK is to ensure that we can still communicate with that. We'll be able to reuse that operator from the vendors. And actually, one of the most important thing, and John also pointed to, for folks to actually attend the SIG meeting this morning or Monday, one of the more important things that actually in the SDK, as I pointed out on this document too, is that we'll create a packaging tools on the SDK. So because obviously as a vendor, Free5GC has a vendor extension. When we built Free5GC operators, it was very tail end, as Wim also alluded to. It was the very end of our integration work that we realized there's something missing. Because initially we knew about the problem, but then we thought it would be easily resolved by adding something called peer config on the so what happened, just for level set, the SMF configurations on Free5GC requires the full context of all the UPF that it's connected to. So that thing is basically almost a replica of the UPF deployment that we already have. And you can just embed it inside. So you cannot just put a UPF deployment, because obviously operators also listens, also watches the UPF deployment. So you have to embed it inside SMF config as a deployment, but in some form. So at one point we thought it was simple, so we just want to point to a bunch of peers. But turns out they need a lot more stuff. They not only need the N4 on UPF, but also the N3 if you have N9, and even the UE pool for your N6. So in that case, we at the end we build something on a config graphs that will be pointing to basically embedded type that contains the UPF that you're connected to for the SMF. So Free5GC does have a okay, go ahead.
Yeah, that is a very common. I'd hate using the word paradigm, but it's a practice in telecoms going back 20 years. I mean, even in core networks that I started out with POTS PSTN, you had this sort of setup where you had the regional boxes out in suburbs, and they had to be connected back into. It was all done physically with wiring back in the day. That's where all this goes back to. But that way of working is very common, especially in config. So it's probably we probably need to think about having some sort of generic way of handling references from one thing to another, so that we don't have to copy entire configs from one place to another.
Well, we do, because in our case, SMF and UPF are not in the same cluster, so we can just get that object. So we do have to dump the object down. So I did ask Wim, who's obviously coming from, so he's not he's not personally working on network functions in Nokia, but he knew about the Nokia configurations on the network functions, particularly because now he's so involved in Nephew.
Yeah.
And then also I would reference back to one of the vendors I work with, or both of the vendors I work with, that on our, so this is not a 3GPP standard. 3GPP never asked UPF to register themselves with NRF.
Okay.
But then it just so happens that for that particular vendor I talk about, which builds the full operators and everything, so their N4 is actually a Kubernetes interface. So they're not using Multis for N4. So in that case, they expose it as an HTTP bus, and then UPF doesn't have a interface into a service bus, but they kind of make N4 part of the service bus. And then that allows them to register with NRF, and then SMF would learn about UPF that way, or UPF can learn about SMF that way. So according to Vim, Nokia also does that. So this, again, I don't think this is unique. As Liam said, it's not unique for 3.5GC, but turns out at least for some of the vendors, the feedback is they don't need something like this for their SMF. So in that case, we decided instead of adding it into, like, say, SMF deployment, we just put it as a config graph. So it's a vendor extension. So extension is created by pointing to that object in config graph. On the current design of CLD, obviously that could evolve, that could change as we move on and find out more. But then for now, the config graph is mainly used for any vendor extensions that is needed. And because we need a vendor, even 3.5GC needs vendor extensions, I would imagine everyone does. And because if everyone does, then when you define your CLDs, the CL needs to be populated into your network function package. So packaging tools needs to be part of the SDK, because by default, when you want to write an operators off of our SDK, you're going to define your CLDs anyway, your vendor extension CLDs anyway, and then when you define them, the CLD YAMLs and everything is already part of the generated things. If you use skill builders or whatever, they would generate that YAML, and then in addition to that, we'll create a particular custom resource for your deployment scenario, and then bundle that into the package. So the package bundling needs to be part of the SDK. So package two it will create is two packages for each of your network functions. One of them is for your operators package, and the other one is for your network function package. And then one of the ideas is you can keep on creating more and more specific scenarios by making the package more and more specific. So it's not only a Nokia UPF package, it's now Nokia UPF package to be deployed on EKS or or Outpost or whatever. Yeah, go ahead, Sandeep.
Yeah, I have a couple of questions noted down here. Few things. When you say nephew compliance, what is exactly does it mean by nephew compliancy?
So Nephew, at least by expectation, is going to continuously publish some custom resource definitions that are Nephew community. I mean, it's not standard. It's our API basically. So Nephew APIs. So what does Nephew do, right? By what it is that the Nephew community, what we build at least for our one, is that it takes a package, a set of packages, or actually just one major package, and then this is the package which, if you hit a certain criteria of your cluster, mainly cluster right now. So let's say you have a package, then you set something that say this package, this source package is the thing that we want to deploy if any cluster comes in with that label. So that's the most common scenario right now. In fact, the only put a scenario right now for our one. So the idea would be if you created 100 edge clusters. I think 5GC, you probably don't see that as much, but then the idea is moving forward when we do RAN, you want to deploy ADU or maybe some of those with CUs, and then once it hits that label, that package profiles with a lot more parameters actually, with capacity per parameter, everything. Because if you integrate the NF topology also, it also carries the idea of capacity and everything alongside with the package. And you're saying that, oh, you hit that label, we're going to automatically deploy this package on this new cluster. But then the big difference is every cluster has its specialization pieces, cluster specific things. So if the cluster is in LA and a cluster is in New York, they could deploy the same DU, but then maybe different capacity, A, and then B, and then obviously different IP addresses and stuff. So those specialization happens on Netfield management cluster for now, and that could change too. But then the interface, however, is something that we're going to fix, which is whatever is generated by the management cluster is at the end, at the very least, within the package that you're going to. So every regions, every sites, every clusters that you're going to deploy the network functions creates a package that goes into the deployment repo. So every one of these cluster has a corresponding deployment repo. So you have a package, which is a template package. So let's say a Nokia UPF, and then Nokia DU in the future, VDU in the future, and then let's say 100 sites matches that label, and then so now you're replicating 100 of these onto 100 different deployment repos, because each cluster is you deploy one for each cluster, and then 100 clusters actually match that criteria, that label. And then each of this, Netfield has what Vim mainly did, Vim's team mainly did during round one is that specialization pipeline. So it takes that information based on, oh, we're going to deploy in on cluster X, and cluster X is allocated with this set of IP addresses, and then that information gets pushed and injected and mutated on the package. So package came in with a custom resource. The custom resource inside are all dummy values, but then at least it'll give you a template of what the resource looks like. And then specialization logic start injecting actual values into those custom resources fields. And then by the time it hits the deployment repos, all the parameters that are needed for you to deploy is being resolved on the management cluster. It doesn't mean it's as specific as I want. So it could be an IP address block where the operators could pick in the future. But then for now, it's like really at the interface level, that IP address is used, that VLAN is used, is all there. When that gets down, the operators listens onto a particular resource and it takes over. And then that resource is what basically our Netfield interface between what the management cluster will do and what the operators would understand is time to deploy something. And then so far, the only thing we did was basically end of deployment. So that is the only important custom resource definition that we did for R1. So UPF, SMF, and AMF, which are the only three things we did with an operator's deploy. We deployed around 10-ish network functions from 3.5GC. The rest of them are just static packages. It doesn't really do much. Not even specialized, because most of the interfaces are primary interfaces, are Kubernetes interfaces. So Kubernetes would just assign IP address and stuff. AMF, UPF, and SMF are the three that we did using the operator model. And then so all of them are basically, it's a wrapper. So we do have UPF deployment, SNF deployment, AF deployment, but then they're basically just wrapper of a structure called NF deployment. The NF deployment by design, probably I'll give you a very quick, very quickly. Key.
I'm a little lost.
Sorry.
Are you
Okay.
trying to describe the compliance that?
No, so Sandeep was asking if what is that interface? Why are we compliant to Kubernetes to Netfield? It is because there's one little things that we do kind of create. Think about that as an API. We talk about it like a million times. Netfield is not here to standardize anything. We are an open source project that is trying to build a thing to be used by telcos. for automating any of their 5G related workloads on Kubernetes. So as a software project, we have APIs. So our API is basically this thing right now. So when you are, so any, like Kubernetes, in Kubernetes, any components could be dropped in and replaced. You don't have to use any of the Vim stuff. You don't have to use you obviously don't have to use our operators because you don't only works at 3.5GC and it's kind of limited in functionality anyway. So you can drop in and use. But then the one thing that you drop in and use is you're writing controllers, no matter where you are. And then controllers by definitions are watching a particular resource. So if you're writing a controller on management cluster, most likely you're watching the package revision resource from Porch, which will give you a handle of the package. So whatever the package content is not it really doesn't matter. So package revision resource gives you a meta resource that would contain whatever package content it has, and then your controller would be specifically written for that content. So you'll be listening onto package revision, and then if the package revisions is a condition, the condition of the package revision is pointing to something that you can resolve, then you can go ahead and resolve it, and then the package content is there for you to take. On the other hand, on the network function side, when you're doing the workload cluster operators, they're also watching a particular resource, and this resource is the API, if you will, that Nephi published, which at this point is something so simplistic that I would imagine many people would probably just have it by default, which is basically just capacity informations and interface informations. And BGP config is the only thing you have. Data network is the only thing that it probably is more 5G specific, if you will, because it actually the only thing inside is basically UE pool and DNN.
So is
yeah, go ahead. Yeah. Oh, you mute yourself. Yeah.
Sorry, Sandeep had his hand up before me.
Yeah. Yeah.
Go ahead, Sandeep.
Yeah. Sandeep, nothing.
Sandeep, you're on mute. You're on mute.
Yeah, sorry.
He's on mute.
So just a follow up onto that, when I asked the question like nephew compliancy, my question was more on related to when we are developing SDK.
So when you're doing an operator, particularly in this case, the only thing you care about is the operator. So if you generate a Nephi network functions operators off of the Nephi SDK, by default they'll be watching a Nephi CL. So in this case, we'll be watching something related to NF deployment. So that's the difference between so on my document I wrote that too. So that's the difference between, let's say you use a QBuilder to create a generic operator versus if you use Nephi SDK, so it would at least create an operator that watches that resource, but then you have a choice to create other controllers that watch something else, or not, or you can use the config raft to start pulling into or poking into the other vendor extension resources if you want to. So those are options. But then at the very least, to tell you that you're a Nephi network functions operator, you need to be watching a Nephi CL.
Yeah. So what is
it's not limited to that, by the way. It's not limited to that. But right now it's those three. So AMF deployment, UPF, SM deployment, UPF deployment.
Yeah. See, CRD are the custom resource definition, which we can write on our own. Right? For example, I can write Samsung CRD and write a related controller for that, and that becomes an operator for me.
Yeah,
and then
that would be a Samsung specific network function operators, right?
Exactly.
That's your own. So, it's nothing to do with Nephi. But then if you want to be something to do with Nephi, because the Nephi management cluster is generating a package that at least contains these resources, then if you're not listening on that resources, then you're not taking advantage of Nephi anyway.
Yeah, so this is a very good point. So this is what I want to understand more on that, because I think I'm not aware of this, because what we have done as of now, we have created a Samsung specific controller and all those things for the playing purpose, and we are able to deploy things.
So I think that's the difference between sorry, let me put in the power on my laptop. There's a difference between taking advantage of like Porch and use Porsche to deploy your Samsung network functions. Or and there's a second thing, which is Nefio, Nefio as a system deploying your Samsung network functions. The reason is we are actually building another set of things on top of this CLDs also. So there's the thing that we have not enabled, but is already there, which is the watcher agent would be watching the statuses of this deployment by looking at that. And then there will be an aggregators that will be collecting it from there. So the system end to end is operating as an assumption that this API exists. So we'll be yeah, go ahead. Yeah, we'll be
Yeah, sorry.
writing. Yeah, go ahead.
Go ahead. Finish your point there, Stephen.
Yeah, okay. Yeah, so I know most people, because they're conflicting points made by different community members by saying that, oh yeah, it could be anyone's stuff and so on. And it is, you can. If you just purely use, say, Porch, and use the Porch functionalities to use GigOps and configure its data and kept tool sets to deploy your own network function or your own vendor's network functions, that's great. And when we love that as Google, obviously. But then at Nefio has other components in the systems. We use Porch. We want to take advantage of Porch by exploring what we can do on a more network functions basis. So Vim, for example, and his team, his subgroup, did a lot of work to fill out all the things that are needed on that package, and generating a package that contains this NF deployment piece information. Not the only thing there. You can have all the vendor extensions in the world here, thousands of them if you really want to. It's a list. But then at the very least, the way we are looking at it is the operators sees an NF deployment, and then they realize the contract that you have with Nefio is, if I see an NF deployments, that basically means that I would deploy this up to a point of ready to go.
Okay.
So that was one of the things that we were kind of expecting. But then so okay, go ahead.
Yeah, so if you look at it, so maybe just to clarify a little bit, if we just go with the Porch way, it's almost like, say, having unstructured Helm charts, just with operators.
I mean, basically, it's almost like, using a different packaging format and then start using cap function as a way to automate, right?
So what Nefio is bringing is, it's actually giving us almost hooks for. Would you go as far as to say it's lifecycle management, Stephen? Standardized lifecycle management across workload clusters. So if you actually buy into if someone goes and says and uses the NF deployment CRD, it's a hook into the Nefio way of configuring and managing workloads across clusters. Mm-hmm. It's as simple as that.
Yeah. So again, because we're an open source project, we build software, and then part of the software we build on both sides, actually both workload cluster and management cluster side, is that you want to automate. Some people said that it may be just examples, but then we're showing you how to automate certain things.
Exactly.
In management clusters. And then at the same time, we also show you how to actuate that once you automated this on the workload clusters. So we key off of that by the fact that we do create a layer of APIs where the management clusters can generate this, and then the workload cluster operators would now understand this and then do what we expect them to do.
And then if you implement those APIs and extend those APIs, you can almost use an API.
In fact, as you can see, we know none of us, and mainly this is written by Vim and I. Let's be honest. And then so Vim obviously came from a network function vendors, and I came from a cloud providers. Neither one of us, and we can say that by representing our company, that we're not standardizing stuff. And B, this is so simplistic. It's more like a signal to us that operator, if I can generate this plus a bunch of vendor extensions.
Exactly,
then we have a behavior. We would know what the behavior looks like.
But the beauty of this is that it's almost like, say, an IP packet You know,
This
you
is
can
basically
load
the
on.
IP package.
Yeah, you can load on whatever you like onto the IP packet. You know,
Yeah.
as long as the header complies, and then you can unload it then with some vendor expensive stuff. You can have vendor stuff on one side to load the payload, and then you can have vendor stuff on the other side to look at the payload. And it works the other way too for the watcher. Yeah, no, I get it.
Yeah. So this is we purposely make this very simplistic. Because we don't want to interfere with vendors, your own secret source and all that stuff. But at the same time, we need an API to say, oh, I'm doing this because I want to deploy something. I want to do this. If let's say in the future we're doing beyond deployments, we're doing some sort of other configurations like slice configurations, then it's not deployment. It's more like a slice config API. And it's also going to be purposely very, very minor if we ever do that. And then that would be one way to tell people that if I see this, the API tells me that I'm supposed to create a slice. But then at the same time, there could be a lot of other surrounding parameters and stuff that you needed, and then more vendor specific, and that should be on config graph.
Maybe persistence or messaging or something could be other things.
All the things that you needed for your to differentiate your network, your particular network functions. We want to have hooks to do that. We not. This is not enough to deploy any network functions. Let's be honest. So this is just there for the purpose of hey, we know how to submit those parameters. That is for us.
So what you're saying is that these are things already available and developed by the Nephew, and if we use them, we can say that we are Nephew compliant. Is it?
Well, if you use that, you are. I don't know if you folks actually done OpenStack. So OpenStack, the Neutron is an API for your plugin or ML2 drivers to be a Neutron networking element. They obviously need to conform to that API. So same thing for us. I mean, we are hoping that moving forward as a software project, Nephew is not just a Porch framework, right? Nephew is a thing that take advantage of Porch, and build on top of that by creating very telco specific functionalities, and then that would be on management cluster. That could be on operator, and operator is not just network function operators. Right? In the future, that could be like infrastructure operators and things like that sits on the workload clusters. And then those things there would be different infra providers maybe running different infra operators, and then at the same time those requirements would also be driven by users in conjunction with the network functions needs to satisfy, let's say, that capacity, and then that information get propagated down. So it will be processed by both the infrastructure operator as well as the network function operator, and in that case that would also be the API layers that would tell infrastructure providers, do this, right? Do SRIOV, do NUMA balancing, whatever that means. And the NUMA balancing it's not even an infrastructure provider problem. It's a network function that comes in and tells us that I have these two pods that needs to be on different NUMA nodes, for example. That's one particular vendor that we work with, because a platform has like two data NICs going out, then they just so happens to map to different NUMA sockets. So they would say, oh, these two pods that I use because they're used for data plane, I would like to schedule them on these two different NUMA nodes. And in that case, that would be reflected by an integrations between the network functions and the platform, and then that expression of intent would also be propagated down, whatever that would become in the future. That could be just an extension, or maybe there'll be like, please NUMA balance these pods, that kind of stuff. And then maybe that get propagated down too.
What is the other? I mean, same question. I think I'm repeating again. I don't know. Is that difference between creating a custom resource, like for example Samsung, and a custom resource which is defined by the Nephew community?
Yeah. So your custom resources could be a lot. And then we'll reference to that. So the reference saying that, so in this case, let's say your Samsung UPF has all 10 different resources that needs to be configured for deployment to happen.
Right.
So the good thing is you no longer need to do any of this in terms of an input, or you can take values out of these and put it as an input into your reference. So these objects are all going to. So what would happen is, let's say you have 10. I mean, let's say for argument's sake you have 10. All 10 of those you created using this SDK. All of them, as the result of the SDK that you want to add, would becomes part of the custom resource, a sample custom resource, would become part of the Samsung UPF package. So when someone goes into either using the PVS, the package variant set, or use the NF deploy topology to say, for anything that matches this cluster label, I'm going to deploy a Samsung UPF with this set of capacity, and then what the Nefio system would do is, anytime this cluster matches that label, it would push a package that is Samsung UPF onto a branch off of the deployment repo for that target cluster. When the specialized logic kicks in and start taking that package, all the custom resources that are Samsung plus the UPF deployment, the Nefio knows how to fill out UPF deployment, so we'll do that. Nefio doesn't know how to fill out any of your Samsung extension COUts. So what you may actually need is you need a Samsung UPF controller or cap functions. So either one of those is fine. And then it will then in terms fill out the input that you needed into your Samsung UPF related custom resources. So all 10 of those may contain overlapping informations, for example. It's possible. And then you can extract it directly from this if you want to, which is probably the easiest way to do it. And then you can figure it out. Your operator can completely ignore everything from UPF deployment if you want to, and then only operates on Samsung UPF related custom resources. But then Nefio as a system would be able to signal to you that Nefio's intent, Nefio perceive an intent that I want a UPF being deployed on this cluster. And then our standard is when you're deployed, this UPF should be ready to go. Meaning that if I have an SMF, it should be able to connect to this. They can start having PFCP packets flowing through. If I have a GNOB, I can create a GTPU tunnel out of that. So we haven't really defined this per se, but then the way we kind of do it for our one is that once the UPF deployment goes down, the UPF is basically ready to go. So it would be great to have that standard behavior moving forward. Although you don't care about anything in UPF deployment, we'll still figure it out. You can ignore it, but then it gives you, the operator would be watching this, because what Nefio as a system would guarantee is when a user intent is to deploy a UPF, the package will contain UPF deployment for sure. So the operator will be watching on that. You can ignore all the fields if you want to, and only check the config reference. That's an implementation. That's your implementation choice. You can do that. But then the big thing is that is the API, right? It's basically the API. My API is asking you to deploy UPF on that cluster. So the operator should deploy a UPF from your vendor's network function.
So the deployment part will still lies on the operator created by Samsung, or can I also
no, even Nefio does not own the network, any network functions. So we roll a sample from FreeFiGC. So the FreeFiGC operator, if you look at the implementation, the UPF deployment turns out to have all the fields that I need to deploy a FreeFiGC UPF. But then carry over what does it mean to take this kind of completely pointless input and translate into deploying an actual UPF is all up to the operator. So the operator has all the power to take whatever information and whatever information you need, actually, because that's up to you. And then the operators would then translating into what kind of stateful sets or daemon sets or deployments that I need to generate, or do I have to like configure certain things in the system to make that happen, or do I have to wait for some infrastructure to be ready before I can actually deploy? So all those logic belongs to the vendor.
Okay.
So
I
again,
don't.
view that the bad thing is because we're all working with telcos that people mistaken us by saying that we want to standardize something. We don't.
Yeah.
we want to create an API. So when this
Mm.
object is embedded inside our package, it basically signals to the operators that we basically get the whole thing from your package in the first place. So now that we fully resolve your package, that should be enough information for you to bring up this particular network functions. So that's our API. That's our API, and that's the API behavior. How you implement that API behavior is strictly up to the vendor or projects. And hence, now going back to the SDK, that's the reason why we need to do packaging, because you may have a lot of, as you said, it sounds like your Samsung has a lot of Samsung specific custom resource definitions, and we welcome that. We do want you to, if you love Nepio, we do want you to bundle that into a CAP package. And then if you want to write CAP functions, which we also welcome for you to do so, you should do it, and we should empower you to do it. And the SDK wants to make that easier. I mean, Vim already wrote an SDK for writing functions that can tap onto the main specialization controller, which is actually by itself watching the package revision object. So if you want to do that, we'll include that into our Nepio SDK. So I already talked to Vim.
Do you
about
have
this.
any video or something where you have done that? Like, you know,
With Vim stuff? He
Yeah.
made like 2 presentations on this, so I can point that to you
Yeah,
later
please.
offline.
Yeah, we probably, in fairness, we probably could do with some more material around that.
I mean, so CAP function has its limitations. CAP function is meant to take in its core, the most common operation it does is you have your dummy sample custom resource, and then it would actually inject values or mutate the CL to fit the needs of that particular instance. So it is very good to do on doing something like this. So if you ever have some cases where on the management clusters you have your network function, your vendor specific logic, which needs to say talk to a management server, CAP function cannot do that. So in that case, you may have to build your own controller, as an example. So we want to empower that too. So the SDK should include hooks for you to create a management controller, a management cluster controller that is specific
Cluster
for the network
controller,
function vendors.
management cluster
Yeah.
controller.
Yeah. So this whole specialization logic pipeline is basically a management cluster controller. The
Yeah, I'll tell
controller
you.
watches the package revision object. When it pops up, you know there's a new package that is cloned. Basically, they're cloned. It's cloned and it's on this particular repo. And then now you can tap into the content. And then the most specific things that John basically encouraged to use is you can look at a conditions. So the CAP files contains a contingent. So a contingent would be like, oh, this is I need this to be fully resolved before I can. The easiest one, before you can deploy a Samsung UPF, the controller would have to resolve that condition, because if any conditions are not resolved, it would never the deployment repo would never so you can create your own conditions on your CAP functions, on your CAP files, your own package. So the SDK creates a package for your network functions. Within that network function package, you can create your own set of statically create your own set of conditions, and you can dynamically create more conditions off of your controllers based on what you actually need during the time of specializations. But then that's way too complicated for now. So let's do like simple conditions by saying that I need IP address block that at least a /30 for my N4, so I can or N6 because I can have at least 2. /30 is what, 4 addresses, right? So yeah, and it's 2, and then you can have those conditions. The controller will understand those conditions that are specifically for your vendor's needs, that may be actually outside of what Nepio can do for you. And then the SDK should empower you to do so also. That you can create a controller that runs on management cluster. I mean, not as much has been talked about in terms of creating a controllers on the management clusters. We call it a pipeline because if you do just Vim's specializations, that controller can enforce some certain level of orders. But then the Porsche system is supposed to be fully asynchronous across the board. So everyone's watching, everyone is taking care of the conditions that they care about.
I'll tell
and
you.
then there's yeah, go
Yeah,
ahead.
one thing I want to be open up here. Like for example, we have been using a few in more or less bits and pieces way. I will admit the fact that we've been able to deploy few NF using the concept of controller and operator using Cube Builder, right? And we had our existing NFs, we could do that. So we more or less saying that we are in the Nephew world or something. But sorry, what I understand, we are not. And there are many, for example, I know KEP function, KPT packages, specializations, how the pipelines of those KPT packages, functions are executed, but we have not taken use of it because we didn't felt the need for it, because for us KPT functions are something like a mutators, right? Which mutates our package content and then creates a variation of it. So we didn't want to do that, so we kept away from it. What I want right now is my understanding of Nephew way, I think is different than what you are saying Nephew compliance way. So can you point us some places, some videos, some documentation using which from the scratch I can onboard my Samsung NFs, existing NFs, into a fully function Nephew compliant operator, not the Cube Builder operator, which we create generally, the whatever you were saying, right? And give us scenarios, pointing the scenario that, okay, if you want to, you can, this is the cases where you should definitely use KPT function. This is the places where you should definitely use the kept to deploy and all such things. So I just want some pointers and
so this is basically what the team is supposed to do. The Nephew SDK team is supposed to be able to do this. Yeah, so we ad hoc did it obviously for R1 because we only have one, and then we are kind of in a mode where we are proving that the system is working. And then right now, so we have no expectations that any vendors will go on board, obviously, for R1. Actually, let's be honest, not anytime soon. Even in realistically speaking. But then the SDK idea is to make life easier for folks to do that. And there is a particular way of saying that. That's the reason why in the document I also talked about conformance testing would come out of the SDK, because obviously when you're saying your Nephew, there should be some expectations what Nephew is. It's not so Nephew. Despite the fact that we're heavily doing it, Nephew is not Porsche. Porsche is Porsche. Nephew uses Porsche. So yeah, Nephew uses Porsche for a particular way of doing it, doing what we want to do. So if you are just doing things where you bundle CAP packages and things, and then use Porsche to drive your own network functions, you can do that. It's probably, you can also come back and say that you learn a lot out of that experience, and thinking that some of the things they've done would help Nephew a lot, and then contribute back to Nephew. But then by default, this is just using Porsche. This is not really using Nephew. Go ahead.
Yeah, we're almost out of time here, so I've just wondered, Stephen, what way do you think we should go ahead from the do we knock this down into a design and then break it up into bits that people can implement?
Yeah, right. So I was suggesting POCs. So POCs are the bits and pieces that are in place. So there are things. There are a variety of this. So one of these is so the first POC is take either Kill Builder or Operator SDK. So I said it repeatedly. So I think everyone knew that we have no interest of building a operator specific SDK for Nephew by itself. So we'll leverage either Kill Builder or Operator SDK directly. So some POC suggestions that I would have would be taking operator SDK or queue builders, wrap that up, and then create our own tools where by default it will create an operator. It will be creating a code that then operators will be watching a Nepio CL. So that would be the core of what it is.
Okay.
But then at the same time, people would still be able to create their CLDs. Then we'll integrate that, and then be, so that's the next step probably. And then the next step would be taking this. If the vendor adds a bunch of other CLDs, the CLDs still get defined as part of this, and then we'll be able to automatically kind of have a resolve functions based on config graphs, right, off of those. And then another independent POC that could happen is package tools. So CAP has tools to allow you to create things, but then the idea is it's not just creations, right? We are also doing updates on the package. So that's one area to explore to see whether or not we can. So when you use the operator SDK to create things, you can, using the Nepio SDK to create your custom resources. We generate a dummy custom resource and start bundle that into the CAP package, and then the CAP package generating tools will be very interesting because you can also write your own CAP functions, and then the tools would help you push the CAP functions as part of the CAP files. So when you dump the CAP packages, it will execute those CAP functions directly, or you want the specialization SDK to execute the CAP functions on your behalf, in which case we use Vim's tools to integrate that. So those are some of the other areas to go for.
Okay.
The other one is completely code, which is the lifecycle management of the Nepio packages, the network functions. If you have controllers or you have Nepio versions that are running a particular versions, and then you have your operators running are watching a particular version of CLDs, they need to be compatible. So that check is going to be part of Nepio system. We'll likely track that on SIG too. But then it will be this team that will be creating that, because particularly you have to have a metadata somewhere embedded inside the package and the operator package to ensure that they are actually compatible when you deploy between the management clusters and the operators, and between the operators and the network functions that you're deploying, the versions that you're deploying for the network functions. And next one, which is if you have existing stuff, either a configuration, things that runs on Kubernetes, or other network function operators that you write for yourself, how to integrate that. So one of the ways that I would suggest is actually one of the ways that I've done by when I integrate with the other vendors that I talked about that has a full bloom operators already written, is I wrote a proxy operator that watches Nepio CLs, and then on the back end it invokes gRPC message. So it would the SDK was supposed to also generate a gRPC server, where the vendors would then link into that gRPC server, and then on the back end they would let's say translate that into the CL that your vendor operators already understand based on that. So you can do that, or if all your vendor CLs are already part of the config graph, then you can just extract config graphs and then push it into your vendor, push it into the Kubernetes cluster API server, and then so your vendor operators would wake up and do stuff. So we can use, so that's the simple CL, a simple POC to do. Even for 3.5GC, I know there's a working 3.5GC operator. So let's say we don't use that, and then instead we write a Python script that would invoke, let's say, Helm, the 5G, the Tor 5G GS Helm. So we can use the proxy operators to invoke a gRPC, which would then generate the value that YAML's input and then invokes the Helm. So that's one of the POC that could prove that I can use a proxy operators to work with your existing whatever that works. If you have operators, it's operator. If you have other configuration-related modules that already runs on Kubernetes, then we can use that. Or not run on Kubernetes. Maybe you run it you run it out of band. The gRPC server would then communicate with your own management servers out of band. So this is up to you. But then the idea is to create a proxy operator that already watches. So the idea is, if you have the proxy operators, one of the idea I was thinking is, why not just use the proxy operators from the get-go? So any things that you as a vendor has that is already working, we can just link that in. So even with the initial use case, which uses a queue builder or whatever to create things, we can also just by default create a proxy operator using the same format. And then we talk about packaging. So packaging, one of the vision I have of packaging, which may or may not be, definitely not an L2 thing, I would imagine, is that we want to have the packaging tools also able to keep on building on top of the package. So the package become more specific, as I said earlier. So it'll be like a 3.5GC UPF package that becomes a 3.5GC UPF package for OpenShift. Then and it'll be a 3.5GC operator, a 3.5GC UPF package for OpenShift on Telus, on AT&T, and then for AT&T East Coast cluster, that kind of things. So initially it will be just 3.5GC UPF package, and then later on it will add OpenShift specific stuff, and the next one will be adding things like, oh, for AT&T this particular cluster, it has this network configurations like Cisco or Arista or Juniper configurations parameters that we can put into as custom resources, and you can. So the packaging tool should be able to just keep on creating, updating a package and make the package more and more specific. So that's one of the things that could happen. And then the management cluster SDK mainly will be Vim stuff. We do have to integrate that into the CLI, the tools that we have, that it will be able to create the functions and able to register that functions. By the time we deploy, it will go with the specialization controller. And some other things that I was thinking about is in the future. I think Sandeep and I had a meeting earlier about the observability pieces. So one of the things that could happen is there's a particular way that Netfield wants to recommend people deploying, say, Prometheus and Istio, and then those recommended ways would be probably more than once. One type could be used as like templates, our deployment cloud service deployment templates, and then as the SDK would also be able to allow the network function vendors to select, oh, I would deploy Prometheus this way, and then Netfield should have an operator that allows you to deploy the cloud service prior to deploying your network functions. And then at the end, it's just validation, which is the conformance test that we talked about. So those are the components that we have. And then, so you're welcome to add more, of course. And then,
I mean, it's already exhausting list of it. I think it's quite a broad vision. I see that.
Yeah.
It's not a one cycle thing, obviously, by the way. Yeah, it'll be as we all said, this is ongoing. Obviously, every time a CLD is updated, we also need to update the SDK. And then every time we have use case where we onboard new cloud services or onboard new other things that is needed, we'll update the SDK to allow people to actually take advantage of those. So things like this would happen. The SDK itself will actually evolve as Netfield becomes more and more mature.
Okay. So how do we proceed in this little group?
Think about what you want to do. It would be nice if there are one specific things you feel passionate about, and then you want to either generate a design doc or build a POC. That would be great. And then otherwise, so there are things that I would probably just do also as a POC, but also as some sort of integrations that I have with other network function vendors work. So this is something that I will there's some pieces that I'll probably do by default. obviously, if community is interested, it'll be nice for community to chip into, because I want this to work for more than business reasons, but it just so happens there are business cases where I'm also building something for.
So
that
for example,
could actually contribute back to the SDK. Let's do it that way.
yeah, I'll be more focused on like creation of those things, like using the cube builder wrapper and all those things. That part, maybe I
Okay.
just have a look
Okay.
on that and get started
Yeah.
with that.
Yep, that would be great.
Yeah, the LCM is probably something that
Mhm.
I think is very important.
Yes.
I mean, we won't get this out into the wild unless that works. You know?
Yeah. I think Niam, you're the one who actually make that point during one of the workgroup 4 meetings, that
Yeah.
that when you bring in Helm, it's not just Helm install and Helm template. It's actually that there's like the whole Helm lifecycle management things that you're taking advantage of also. So I'm not saying we
Yeah.
replicate this, but then specifically for Nephew in this use case, we also need something LCM related.
Well, I mean, we don't have to replicate it, but we have to be able to provide equivalent functionality to what already
That's right.
exists, or the people would just say, well, I'd love to use it, but I can't because it doesn't do this, that, and the other, you know.
Yeah.
And
Yep.
it doesn't have to do everything, but you have to be able to update things, and you have
Mhm.
to be able to delete things, and you have to be able to get the status of things. Code like
Mhm.
so.
Mhm.
I guess we should work on that.
Okay.
Okay.
Cool. So we can communicate on the channel on how
Yeah.
things
Yeah.
should proceed.
And maybe the
we
YouTube, if you upload the video to the somewhere, we can
Yeah.
just refer it back, because there's a lot of information you have shared, and
Okay.
maybe I can go
Yeah.
back to that again and again to
Yeah.
use it as a
I can
reference
also
point.
kick off a doc on what we want to do in
Yeah.
terms of say like a month before the end of September or something.
Yeah.
And then as I mentioned on the channel, our users are network function vendors. So I'm very happy that 2 network function vendors showed up. Our users are network function vendors. So periodically we do want to show our progress to network function vendors. So if WG4 can invite network function vendors to look at the progress and then get feedback, that would be great. Otherwise, maybe we use like one or somewhere to do that too.
Yeah, I can do that, but today I don't know whether we have enough content to conduct a WG4 meeting. What do you say, Liam?
From this, well, I think we can give them a short update, I suppose.
Yeah, I mean, update status is fine, but then what I'm saying is, once we run this in sprint, and then once we get something, we integrate something, and then something to show people, we can use maybe WG4 work group as a platform to ask some network function vendors to join, and then seeing, oh, this is the Nephew SDK of where the direction we're going. This is what we've built so far for a particular area.
Absolutely. So what I request you to just share this YouTube link so that I'll post it to the WG4, and I'll say that for today's meeting, right, we're gonna discuss more onto that, like what we have discussed. People can see, and more people can join, and you have already described the points which you have vision. So maybe people can start picking up that. So maybe we'll focus more on that today in today's meeting. I mean, Tuesday meeting.
Okay.
Tuesday. Right.
Okay.
Cool.
Yeah. Thank you.
Well, thank you.
Yeah.
I'll upload this. I'll kick off a doc, as I said, to see who's doing what.
Yes.
And then we'll kind of line it up.
Yes.
And then we'll see whether or not we do meetings in either SIG 2 or we branch off to different meetings.
Right. Thank you.
Thank you.
Okay. Talk to you later. Cheers. Bye-bye.
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 Hey, Steve.